Kelly. This is section 4.2. I'm so excited today. They're laughing at me because I'm so excited. 4.2 is the most basic rule for finding a derivative. Yesterday we did ugly things like finding the slopes and finding the limits and all that good stuff. And I'm going to show you, okay, what we can do is when I give you this information and I'm saying find the derivative at this point right here, I'm going to show you a rule of how to just do the thing, plug the number in, and be done, right? You don't have to do this whole process. Same thing here. You do the thing, you plug the number in, and you're done. And then you don't have to do the whole limit process and all that good stuff, okay? So here are the rules. These you're going to use like every single day going from here on out, okay? So pay attention to this. This is really important that you know it, but it's super easy to do. Okay. All right? Are you ready?
Yeah.
Okay, I'm going to do some examples up at the top here before we do anything else, okay? Before we do anything else, let's do some examples up at the top here just so you can get the hang of what a derivative does, okay? So let's say I'm finding the derivative of, like, let's say x to the 6th power, okay? So do this example. Then let's say I'm going to do another example, y equals, let's say I have 4x squared, okay? Now I'm going to do one more example where I have y equals, I don't know, 7, let's say. Okay, y equals 7. All right, here's my derivatives. Okay, you ready? Blink and you miss it. This is a super, super easy thing. Okay, the rule for finding a derivative, and this is what's called the power rule. This is the just regular thing for exponents, the power rule. The power rule says this. If you're trying to take the derivative of x to the nth power, whatever n is, like x to the 6th power is the first one that we're going to do. Okay? The rule for finding a derivative is the n comes down in front of it. You leave the x and then you take it to the n minus 1 power. Okay? That looks like a really ugly formula, but it's super easy, guys. This is how it looks, okay? So in the first example, x to the 6th power, to find the derivative of that thing, n is 6 in this case. So the 6 comes down in front, right? So this is 6x, but now it's to the 5th power. That's the derivative of him. Okay? That's it. That's how you find his derivative. Huh. No more slopes, no more stuff like that. That's disgusting. That is his derivative. Okay? Now, if we do this one, n in this case is 2. But the reason why this is just a little bit harder is because there's a 4 already down in front. So if I move that 2 down in front, we multiply them together. So this guy will end up being 8x to the 1st power, right? We move the n down in front, and then we subtract from the exponent, and that is all, right? All right, now here's this deal. If we have 7, if we have 7 and there's no x on it, okay? If it helps you, you can think of it as this has an x to the 0 power on the end of it, okay? If it has x to the 0 power, right? Like 7, if it's just 7, it has x to the 0 power. We move the 0 down in front, and we have 0 times 7 x to the, technically x to the negative 1st power. But if we're taking 0 times 7x to the negative 1st power, the whole thing is just going to be 0. So if you just have a number here, like 7 or 492, and you're taking the derivative of a number that doesn't have an x, his derivative is going to be 0. Okay? That's what we have down. The constant rule is the first thing that we have, okay? It says that if you're taking the derivative, and this is the notation that they use for finding derivative, they say d over dx. This just means the derivative. Okay, they use that notation. Don't let that intimidate you. D dx, that just means find the derivative. And c stands for a constant. A constant is just a number. So when you're finding the derivative of a number, it is 0. So the derivative of y equals 7 is 0. The derivative of 0 is 0. The derivative of negative 3 is 0. The derivative of this thing, where k is a constant, so this is a number, and pi is technically a number also, right? So this whole thing is just one big number, so his derivative is 0. Every time you have a constant, his derivative is 0, okay? I just gave you this formula, and this was the formula for the power rule. What?
It is.
Okay, this is the derivative for the power rule. Now, it gets harder. Okay, example 1 is easy.
3x squared.
3x squared is his derivative. Okay, now it gets a little bit harder because number 2. Okay,
1/3.
now Some of these problems you will have to, before you find the derivative, you have to rewrite them. Like on your homework assignment, if you look at your homework, there has a place down below here where you're given like the original function and then it says rewrite it, okay? You have to do that before you actually find the derivative, okay? So in this example, the cubic root of x, we're going to rewrite it before we take the derivative, and that's x to the 1/3 power, okay? This one's hard, follow along. Are you ready? So the 1/3 comes down in front, we have x, and then I'm gonna subtract 1 from the exponent.
Negative.
Okay, what's 1/3 minus 1?
Negative 2/3.
-2/3, okay? Now, we're gonna fix this thing. I don't ever like negative exponents, okay? So to fix it and make it have a positive exponent, we move it down to the bottom, right? Okay? So technically 3 here is already down on the bottom, so what we can do is we can leave the 1 on the top, the 3 on the bottom, and now this is x to the positive 2/3 power on the bottom. Does that make sense?
No.
No? No? Okay, do you see where we got negative 2/3?
Yes.
Yes. Technically, when this x is off to the side over here, he's in the numerator, right? But if we move him down to the bottom, he's down with the 3 now.
We moved the whole thing.
You move the x. The x is the only thing to the negative 2/3 power. So we're moving the x to the bottom, so now he's with the 3 and not with the 1 anymore. He's with the 3 now, right? So we've moved down to the bottom. This is his derivative, but negative, or to the 2/3 power means the cubic root of x squared. If we want to fix him and make him look really nice, 2/3 power means the cubic root of x squared. That is his exponent. Or that's what he looks like. That is his derivative.
All the way.
That's what his derivative is. It depends.
We should do another one of those. Can you make
Okay,
those?
we're going to do another one of those like probably down below here.
How about we do it?
We'll do some more. We'll do some more. Let's talk about number 3. Okay? Now, number 3 is another one where you're going to have to rewrite it, okay? The x squared is in the bottom. So, what I'm going to do is I'm going to move him to the top, okay? So that when I move him to the top, he looks like x to the negative 2 power. Okay, and now that he's in the numerator, now we can just do the derivative like normal, right?
Negative 2x.
So negative 2 is coming down in front, right? X to the negative third. If you subtract 1 from negative 2, you can get negative 3, okay? Now let's fix him again by moving him back down to the bottom. So he will be negative 2 on top and x to the positive third on bottom. Does that make sense? That is his derivative. Okay, we don't have to do the slopes and the limits and the anything anymore. We're just doing it using this rule. Okay? Now, to our next section, in section 4.3, we'll learn another 2 rules called the product rule and the quotient rule. They're not any harder. It's just you have to use those rules when you have uglier equations, right? Okay? So this is the power rule. This is when you have just polynomials, right? Like just x squareds, x to the exponents, that type of thing, okay? Later on, we'll learn other rules for when the equations are a little bit uglier, but this right now is the most basic rule that you can get, okay? Good? All right? Now, here we go. They're saying find the slope of the graph of this function when x is -1, x is 0, x is 1, okay? So what do they mean when they say find the slope of the graph? What's another name for the slope of a tangent line? Slope of the graph is a derivative. That's what the derivative stands for. So it says find the derivative when x is -1, x is 0, x is 1, okay? So,
0!
Do you guys remember what x to the 4th power looked like? It looks like a W, but since he has nothing with him, he's actually kind of more of a flat tire right here. He looks kind of like this. Woo. Let me make him look a little better. Flat tire in the middle, and then he goes back up, okay? So what we're trying to do is we're trying to find the slope at -1, which is like over here, the slope at 0, which is here, and the slope at +1, okay? So I can tell right now that if I
Zero,
draw a
zero.
tangent line at 0, 0 is going to be at 0. So I'm gonna put 0 question mark here because I think that's what he's going to be. Okay. At -1, I'm trying to find the slope of that guy. At +1, I'm trying to find the slope of this guy. Okay. You will not have to graph these. I'm just providing the graphs so that you understand what we're finding. Okay. So this is what we're trying to do. Okay. So we have the graph of x to the 4th power, and I want to find his derivative. Okay. What's the derivative of x to the 4th power?
4x cubed.
4x cubed, okay? Now that's the general antiderivative. If I want to know specifically what the slope is at individual points, now I plug those x values into the derivative. So 4
-4
times -1 to the 3rd is just going to be -4. So this guy, this line right here, has a slope of -4. Yeah?
Wait.
Do you see that? That guy has a slope of -4. Okay, specifically at -1, I just plug -1 in for x after I find the derivative, and I get a slope of -4. Now, if I'm trying to find 0, I plug 0 into the derivative. So 0 to the 3rd power is now 0. So this line right here, this second one, has a slope of 0, which we said was true, right? We said it was 0, okay? If I plug in a +1, which is this guy right here, we have to find his slope. His slope is probably going to be a +4, right? 4 times 1 to the 3rd power. Yep, +4. So this guy has a slope of +4, right? Does this make sense? So finding the derivative gives you an equation, 4x to the 3rd, and then I can just plug in wherever I want to find the slope at that point, right? Okay? Yeah? Okay, so before we move on to the next set, I want to go back up and just look at my paper, because you guys probably have this tucked away somewhere. Okay? Just look at my paper. And let's just talk through like number 6 real quick. Hold on. I'll go back down. Okay? If we're trying to find the derivative of this guy at this point right here. Okay? What's the derivative of x squared?
2x to the 1st.
2x to the 1st. Okay? What's the derivative of -9 or -9?
0.
0. So this is like 2x plus 0. Now, if I'm looking specifically at the point 2, -5, I would plug 2 in, right? Okay, if I plug 2 in here,
It's 4.
you get 4. Look at all of that work that we did to get the answer of 4. Dumb. Now we can just do it really fast. We did all of that work to get to 4.
Why did we have to be taught that?
Yeah.
Because it's showing you that a derivative is a slope, and so we use the slope formula. And then somebody somewhere came up with the brilliant idea that like, hey, if you do this easy, like tricky thing, it actually works too. So like yesterday, yeah, every year I kind of debate on whether like, should we skip over 4-1 or should we do it? Well, I just do it, and that's why we do it all together. I don't assign any homework from it. It's just because it teaches you that, like, hey, a derivative actually means a slope. And that's kind of like, 4-1 is kind of the bridge between, like, why we learned limits in the first place to, like, now how it plays into a derivative, okay? So 4-1 is the limit connection between derivatives and limits, and now we know the shortcuts, okay? So we know how to find these really super quick and easy, okay? Now, there's one more thing that we can do beyond just plugging the number in, okay? So let's do this example. Find an equation of a tangent line to the graph of x squared at the point -2, okay? I'm going to graph this one also. You won't always have to graph it, but I'm just going to graph it so that you see what it is exactly that we're finding, okay? X squared looks like this, yeah?
Yeah.
And -2 is this dot right here-ish.
4.
This would be at -2, 4 hitting the graph, all right? What I'm trying to do is I'm trying to find this thing, okay? But this one is asking for the equation of the line, not just the slope of that line, okay? So here, it's just one more little step further, okay? So when we're trying to find a derivative, we're going to still do the derivative. The derivative is the slope of the line at that point, okay? And then we have to go one step further and find the actual equation of that, okay? So I'll show you how this works, all right? Let's just do what we did in the last example. We have x squared. His derivative is 2x. And if we plug -2 in, 2 times -2 will give me -4. So this guy has a slope of -4, right? Okay? But I don't just want the slope. I want the equation of this entire line right here, right? Well, if it's a line, it's a linear function, right?
Yeah.
Okay, what does a linear function look like? Y equals mx plus b, right? Okay, we just found m, right? Didn't we just find m? We found m was -4. Now, how do we find what b is?
You plug -2.
You plug -2, 4 in, right? Okay, so 4 is here, -2 is here, and we find b. Okay, -4 times -2 is +8, but then I subtract the 8 to the other side, so b will be -4. So if I'm looking at that entire line, we know that the slope is -4, great, but the equation of that entire line is y equals -4x minus 4. I can do better than just finding the slope. I can find the equation of the entire line, right? So when they ask for the equation of the entire line, it's just algebra. After you find the slope, after you do the derivative, it's just algebra after that, right? Good?
No.
Okay? No. Okay, you tell me where I need to back up to.
Where did we get -2 for on the...
Okay, so they gave me, Maddie, they gave me the x coordinate of -2. And we said in our graph, if this is x squared, -2 as an x coordinate will have a y coordinate of +4. Does that make sense? Because we plug it into the original function. Yeah. So then we use that later on to find the b. Okay? Maybe? -2 on the graph will be at -2, 4. Are we still confused? Are you okay, Maddie? Uh-huh. Okay. All right, so let's get into these ones. These are really ugly equations. Kind of ugly equations. So we have an original function. We want to rewrite it, okay? So 2 over x. I cannot have x's in the bottom. So I'm going to move it to the top, and when I rewrite that, that will be 2x to the -1, right? If I move it to the top, it becomes the -1 power, right? Okay,
Yeah.
now I want to find the derivative of him, okay?
You moved the -1.
So the -1 comes down in front, so it's -2x to the
-2.
-2. -2x to the -2, and now I want to simplify because I don't want negative exponents.
Now you gotta
Put -2
over
over
x
x
squared.
squared.
Yeah, look at that. Look at how smart you are. We like this stuff. I like it. I like it. Hey, Maddie. Okay, because this is x to the positive first power, right? On the bottom, though, but when I move it to the top, it becomes the negative first power. Yeah? Good? No? Okay. Number 2 is hard. Ooh, look at that. What a mess.
That's yucky.
Number 2. Okay? All right. I don't like the cubic root of all that good stuff. What's the exponent on x
X to
right now?
2/3.
X to the 2/3. I'm going to switch it to 2/3. Okay? Good?
What's a third? That's not. Which means if you put that on top.
So if you put that on the top, and I'm going to slide him off the top. I'm going to have 1/2. So I'm going to detach it from there. But if I move him to the numerator, he will be x to the -2/3, right?
Yeah.
Because technically putting him off to the side is the same thing as putting him in the numerator, right? Okay. Do we see how I switch that around if I moved him to the top?
Yeah.
Technically moving him to the top is like putting him on the outside, right? Okay. Are we good so far?
Sure.
Do we know what we're doing?
No.
No? Maddie, are you all right?
Yeah.
Yeah? Okay, now
This.
we want to find the derivative. So we take the 2/3, -2/3 down in front, okay? And we take -2/3 times 1/2.
Yuck.
What will that be?
I did this earlier.
Cross out the 2's. Cross out the 2's.
Huh?
Yeah.
1/3.
Right? -1/3. X to the, now I subtract 1 from this. What's -2/3 minus 1? Or -2/3 minus 3/3?
5. -5.
-5/3. Okay?
Now move that to the bottom.
Okay, are we doing okay so far?
Oh, whoa.
Yeah?
Where did we get -5/3?
So our -2/3 exponent, we have to subtract 1 from that, which is like subtracting 3/3. So -2/3 minus 3/3 is a -5/3. Are we doing okay, Maddie?
Wait, just repeat that real fast.
Okay, so do you see where we get the -2/3 power from? when we rewrote him, okay? So the rule says that we have to take the negative 2/3 down in front and we multiply those together and we got negative 1/3. So when we multiply these together, we got negative 1/3. But then we put x and then we have to subtract 1 from the exponent, right? So I have negative 2/3 and I'm subtracting 1, okay? As a common denominator, that's negative 2/3 minus another 3/3,
This is fun.
which is negative 5/3.
I hate it here.
Are you doing okay, Maddie?
Move it to the bottom now.
Okay, now we're going to move it to the bottom. Okay, whoop, I lost my 3.
Can we leave
So,
3 on the bottom?
The
and
3
that's
stays on the
big?
bottom, yes. So this is negative 1 over 3x to the positive 5/3 now, right? Because I moved him back down to the bottom with
But we
the
don't
3.
like that.
So it's
Okay.
the big root, or the
Negative
cubic root of
1
x.
over 3
Oh.
cubic roots of x to the 5th. And that is him completely simplified. That's his derivative, right?
I didn't like that at all. I'm just gonna tell you that right
But
now.
it's kind of like a puzzle. Like, it's just like, you know,
Oh my gosh, we
whatever.
have a backside on this. I hate it here.
You're going to be all right. Is this? Okay. Yep. Okay, we'll get through these 2 and then we'll stop. Okay, good? All right. Okay, number 3. Okay, I don't like that there's parentheses there. Let's fix that.
Distribute.
Let's distribute, okay? So this would be 5 over 8x cubed. Okay, now, I want to put the x to the top.
So it'd be negative.
So the 8 will stay on the bottom. So this is 5/8 x to the negative 3rd power. If I move him to the top.
Where did we get 8x?
Okay, because 2x to the 3rd, you're taking the 2 and cubing it also. 2 cubed is 8. Maddie?
Huh?
2 to the 3rd power is 8. Yeah. Okay. So now the x to the 3rd power, we move him to the top, which is kind of like sliding him off to the side. Okay. And now we do all the same stuff again. Are we good to the rewrite step? No?
Yes.
Yes? Okay, so now
So
we
take
multiply
it
the
times
3 down in
3.
front. Okay, so I'm going to multiply him by negative 3. And what helps me is to do him as a negative 3. Negative 3 over 1, right? That's what he is as a fraction.
So 15
Okay.
over 8.
So this will
No.
be negative 15 over 8, x to the negative
Squared.
4th power,
Oh, yeah.
right? Because he's negative. Okay?
Wait.
Yep.
What happened to the 5 over 8?
Because we multiply it by 3. So 3 times 5 is 15 over 8 times 1, which is 8.
Which means that the final thing would be
Huh.
Huh.
negative
What a deal.
15 over
Negative 15
8
over
x to the 4th.
8x to the 4th. That's his derivative. You guys are doing such a good job. The derivatives are not hard, but they really test your knowledge of like what you're allowed to do with exponents, right?
This is where
Like
trig
that's the
comes in.
hard part. Woo! What?
This is where trig came in.
I know. This is like trick stuff. Yeah. All right, last one, and then we'll stop for the
Why'd
day.
you laugh like that? Like evil. Like I'm gonna cry.
What? Me?
Yeah.
I don't know. Okay, this one, number 4. All right, I don't like that negative exponent.
Move it to
Okay.
the top.
And the
Oh,
deal
you gotta
is
FOIL it first.
that like here, let's see, like here, okay, this x to the 3rd power, we only move the x to the 3rd power to the top. But since the 3 is to the negative 2 exponent, I'm going to move them both to the top. Both to the top. And we're going to see what happens there. So the 7 is just chilling. If I move the 3x to the top, he is now squared. And really, I have nothing left on the bottom. So you can put a 1 there if you want to. It doesn't matter, right? Okay. So now let's simplify some stuff. Let's get rid of our parentheses.
9x squared.
So this is going to be 9x squared, right? But there's a 7 there. So this is
63.
63x squared.
Where did we get 9x squared?
Okay, because 3x squared, because the 3 is underneath of the parentheses also, we have to square him as
Is
well.
that our rewrite?
That's our rewrite step. This is our rewrite step. We haven't yet taken the derivative yet.
What? Times
That's
2.
just rewriting.
60.
Okay. All right, are we doing
One.
okay, Maddie? Are you all right?
26.
26.
Okay, so this guy, now we want to take the derivative. And this one's going to be the easiest one to take the derivative because we don't have to do anything afterward. We take the 2, move it down in front. 63 times 2 is 126. X to the
1.
1st power, or just x,
And then
and then he's done. You don't have to move anything, right? We don't have to do like a simplify. Our simplify step is gone because he's done. He's simplified. Okay?
We can do the first.
Okay? You should be able to on the homework assignment. We'll stop there, and we won't do this next step. But you should be able to do like, I don't know, the first page maybe.
How do you do 5 and 6 though?
Actually, you really can do probably a bunch of it.
5 and 6.
What?
5 and 6.
How do you do 5 and 6? Well, that's a good question. Number 5.
Yep.
Let's look at number 5.
Yep.
So all you're gonna do is when you have a bunch of them together, this is what we're gonna talk about on the back side, but it's pretty easy. This has 3 pieces, right?
1, 2,
What's the
3,
derivative of this guy?
-4.
Negative 4
X.
x to the first power. Okay. What's the derivative of a positive 3x?
3. Just
Plus 3, right? What's the derivative of
0.
negative 6? 0. So you can put plus 0 if you want to, but I'm not going to. This is his derivative. So all it's saying is that if you have multiple pieces, you just take the derivative of them individually, and that's what you got. That's all.
Sweet.
Okay?
Wait, but what about it's -1/2?
So what are you talking about? That doesn't matter.
You need to rearrange it.
No, you don't have to.
So -1/2 times 2 is 1. This is -1.
X to the first power. Yep.
X
Okay. Very nice.
minus.
Okay. All right. There you go. Okay. All right. It'll take a little bit of more practice before you get the hang of it, but yes, that's what we've got. Okay. Good. Monday we will finish this and we'll move on to, not move on yet on Monday. We will no. Monday we are not in school. Tuesday we'll finish this. Wednesday we'll move on to product and quotient rule.
Did you?
Okay. But you're gonna like the rest of this chapter.
X,
It's
Y.
really not too bad. Okay. Everybody say bye, Ellie.
Yeah, I just said 3 minus.
Nobody wants to say bye. Okay.